Good morning, everybody. I hope you had a lovely weekend. The sun was out, it was beautiful. We were out in the garden doing a little bit of gardening and just sitting outside, and it was nice. So I trust you've had a lovely weekend as well. This is week 2, day 1. Let's jump right in. Numeracy up first. Okay, so as you can see, our learning intention is at the top. Today we're going to be looking at weight, and in particular we're going to be reading scales to the nearest 100 grams, or, which we'll discover, 0.1 kilograms. So go ahead, pause the video, take that down as your learning intention in the book, and then we'll take a look at the first diagram. Right, let's take a look at our first diagram. Here we have 0 kilograms at that end and 1 kilogram at this end. Now you may want to pause the video in between my questions as we get warmed up, and the first one is, how many divisions are there between the 0 kilograms and 1 kilogram? Good, you should have spotted that there are 10. So if there are 10 divisions, what does each one of those divisions represent? Hopefully from your previous knowledge you would have said 100 grams. Okay, 100 grams. Now, if each one of those divisions is 100 grams, what would this division be here? Which isn't working. Bear with me a wee sec. Which one is this one? You can see that it is smack bang in between 0 kilograms and 1 kilogram. So this would represent 500 grams. So each one of these little marks represents 100 grams. This represents 500 grams. Now you can see I've added an arrow to the diagram. This arrow is in between what two markers? Hopefully you would have answered 600 grams and 700 grams. Now I need you to look carefully at it because it's definitely in between 600 grams and 700 grams. So questions you might get are like this. Is it near to 600 grams or 700 grams? What 100 grams would it be closest to? Hopefully if you take a look at it, you can see that it is actually closer to the 600 than the 700. So your answer would be it is nearer to 600 grams. Let's have a look at our next diagram then. Now this time we're not starting at 0 kilograms, we're starting at 5 kilograms and going all the way up to 6 kilograms up here. Have a look at the diagram now. I've put an arrow on. Now, my question here is, what is the measurement that the arrow is pointing to the nearest 100 grams? So what is the measurement that the arrow is pointing to the nearest 100 grams? If you count, you can tell that each one of these little increments or marks is 100. So you've got 100, 200, 300. Now it's closer to the 300 than the 200. So you could say that this is 5 kilograms and 300 grams to estimate. Right, let's go on down to our next diagram. Have a look. How many increments did we say there were in between the 1 or 0 kilograms and the 1 kilogram? We said that there were 10. Now, the question then is, if there are 10 divisions in this, what fraction of 1 kilogram would each of those divisions represent? Well, if there are 10 of them, it would represent a tenth. So my question is, what is that as a decimal from there to there? That is 0.1. So we could also refer to that, instead of 100 grams, as 0.1 kilogram, because as we know, 100 grams is 1/10 of 1 kilogram, and that is where we get 0.1 from. So what would this one be then? Let's go. 1, 2, 3, 4, 5, 6, 7. We could say it is 700 grams, or we could say 0.7 kilograms, because that is 7/10 of a kilogram. So in today's work, you're going to be asked to use estimates just like that, using decimals of kilograms and also to the nearest 100 grams as well, reading lots of different scales and finding out what is the nearest 100 grams or 10th of a kilogram. Good luck, squares. Okay, triangles, we are up next. Now triangles, we're not quite finished our topic on fractions just yet, so we're going to continue with that. Today we're going to be looking at finding 1/6, 1/7, 1/8, ninth of a set and represent those things as fractions. Okay, let's jump straight in. Alrighty, triangles, there's your learning intention for today. Like I said, we're going to be finding 1/6, 7th, 8th, 9th of a set. Okay, so pause the video, and you may want to pause the video a few times as I pop questions to you in this little introduction. Right, okay, hopefully you've got that down. Let's take a look at my first diagram. Now, here I have a set of counters. How many counters are there? Quick count tells you there are 6 across the top, 3 down here. 6 times 3 quickly is, that's right, 18. We've got ourselves 18 counters. Now, I'm going to divide this set of counters up like so. Having a look at this, we can see that I have divided the 18 counters into 3 rows. Okay, 3 rows. 18 divided by 3 is 6. So in each row, as I've divided it up into 3, we have got 6 in each of those rows. So what we can say is that 1/3, because this is divided into 3 parts, is 6. So you could say 1/3 of the overall 18 that were there equals 6. So how did I get that? I did 18 divided by 3 to give me 6. So the total amount divided by how many I split it into gives me 6. Okay, let's look at my second set. Now there are still 18 counters here, except this time I'm going to divide them another way. This time I have divided them into sets of 1, 2, 3, 4, 5, 6. So what do the counters and lines now show? It shows that 18 divided by 6 equals 3. So therefore 1/6 of the whole shape is 3. To find 1/6 therefore of something, you would divide it by 6. Okay, so to find sixths, you divide by 6. To find thirds, you divide by 3. Okay, so this technique that we have looked at, by dividing the number by 6th, which we set up here, will give you the answer to 1/6 of a set of things. To do the 7ths then, there are no prizes for guessing that. To figure out a 7th of something, you would divide it by 7. For an 8th, divide it by 8. For a 9th, divide it by 9. So, some quick fire questions for you. Here we go. So, we have worked out the 6th. What would 1/7 of 49 be? So your overall number, or overall counters in that case, would be 49. Divided by 7 gives you 7. Well done. What would 1/8 of 56 be? So imagine 56 counters. Divide it by 8, you should get 7. And finally, what is 1/9 of 36? 1/9 of 36 would be 36 divided by 9 equals 4. So here we go. Here's some practice on this for you today then. So we have bears and penguins, dogs and cats in different sets, and you have got to find 6ths, 8ths, 7ths, 9ths of those different sets. And it continues then, just like the questions we've just practiced, finding 8ths of numbers, 6ths of numbers, 9ths of numbers, and so on. And there's a bit of a problem solving one down there for you to have a go at as well. Good luck, triangles. That is you for today. You may go ahead and get started. Where are we? There we are. Okay, circles, you're up next. Circles, we have finished our fraction topic for now. We're going to move on and do a little bit of subtraction. So today we're going to be looking at the expanded method of subtraction. So we're going to look at how much each of the columns are worth and expand that out in our subtraction to see what that looks like when we subtract like this. Now, this will not be the way that you subtract normally. It's just to make sure that we understand the value of the digits that we're subtracting. Today there will be no exchange, okay, so no need for more on the floor, go next door. This will just be straightforward subtraction, looking at the expanded written method. Okay, circles, let's jump in. Alrighty, circles, there we go. There's your learning intention. So pause the video, copy that down into your book. The learning intention is subtraction, and we're looking at the expanded written method with no exchange today. We will keep it nice and straightforward. Okay, pause the video, take that down, then take a look at our first example. Dun dun dun. What's going on here? So here's the way the calculation is normally written down. In this case, it's 368 subtract 42. Notice how neat and tidy Mr. Hayes' calculation is. 1 digit per square, all nice and neatly, and the symbol outside of the sum. Make sure yours are set out the same way. Now, that is what it normally looks like when it's written down. Then, this is the expanded version. Let's take a look at what's going on. This column, this number is worth 300. That's where this comes from. Okay, so you're showing me that 3 represents 300 when it's written like this. Plus, and we say plus because this number is made up of 300 plus, this would be 60. It's in the tens column. 10 sixes are 60. So 300 plus 60 plus, in the units column, we have the 8. That's where the plus 8 comes from. Expanding the 40 out and partitioning this out, it looks like 42 means you have 4 tens, which is 40, and 2 units, which makes up the 2. Now, put that all together, you would have 368, you would have 42, 368 subtract 42. Well, let's do this calculation. 8 take away 2 gives me 6. 60 take away 40 gives me 20. 300 take away, boom, boom, nothing there, gives you 300. 300 plus 20 plus 6 is the answer to this sum, 326. Okay, pause the video, rewind the video, and read that over again. Listen to the explanation again. Make sure that you understand it. Then let's do another example together. Okay, so over here we have 368, and this time we're taking away 242. So let's expand this out. First of all, how many hundreds do we have in the first row? We have got 300. It's 300 plus, again, 60. We have 368, so we have to put our 8 in. This time in the bottom row, we have 200. That's how much the 2 is worth in this number. It's worth 200. Plus 40, because the 4 is in the tens column, that's how much it's worth, 40. Plus, easy peasy, in our units column, it's worth 2. So, we are ready to complete this calculation. There's no way you would do that without a ruler. So let's have a go at the whole calculation. 8 take away 2 is 6. 60 take away 40 is 20. 300 this time take away 200 is 100. Don't forget we've got to add this all back together again because it shows the overall value of the number. 100 plus 20 plus 6 is 126. If you were doing this calculation normally, you would end up with 126. This is the expanded written method. It's a good way of demonstrating you know the values of the numbers in the calculation. So we're going to begin with this to demonstrate our knowledge before we work on to the standard written method, which is the typical way that everybody does subtraction. This is a good way of demonstrating your knowledge. You may want to watch the video over a few times to make sure you understand what's going on. If you're ready, good luck circles, let's jump into your work. So on this page you're going to demonstrate and complete the remaining calculations for the expanded written method here. It'll take you through a few examples, each one of them asking you to do a little bit more each time. Then the second sheet will ask you to create some of your own calculations and demonstrate the expanded written method in each of those. Circles, good luck with that. I know you'll do a great job. Alrighty, alphas, bravos, literacy time. Now, today we're going to be taking a look at synonyms and antonyms. We have talked a little in class about this and got this language into our vocabulary. These are dead straightforward. Again, it's a fancy pants word for something dead simple. So let's take a look at what they are. Synonyms. Synonyms are words that have the same or similar meaning. Okay, for example, you might have the word expand and you could exchange that word for the word swell, for example. An antonym is completely the opposite. And what I mean is antonyms are words with the opposite meaning. Okay, so for example, you might have the word conceal, which means to hide something, and you might want to use the word reveal, which is the opposite of to hide something. It's to show it off. Now, why do we need to know synonyms and antonyms? Like I always say, it's good to know these words so it can improve your writing. You might be writing a story and you want a different word to explain something, so you might use a synonym. You might be trying to show the difference in some of your writing or contrast one scenario to another. Therefore, you might want to use an antonym. So it's good to know what these words are and also how to use them. So you're going to have practice at finding synonyms for other words, finding antonyms for other words, and then using them in a little piece of writing as well. Make sure you try and get up the language ladder as high as you can and use really good synonyms and really good antonyms, okay? So if I say darkness, don't go for black, really boring, simple ones. See how high you can get up the language ladder using this. Okay, and my cheeky charlies, we are going to be looking, let's try that again, cheeky charlies, we are going to be looking at alphabetical order. Now, alphabetical order, what do we know about that? Well, the alphabet is made up of the letters from A to Z. The alphabet goes from the letters A, B, C, right through to X, Y, Z, so there is an order that letters appear. When we're putting things in alphabetical order, it is about putting those words in order that they would appear if they were in the alphabet. So, it's a system used to arrange items so we can find them quickly. So if I was in a library, for example, this is why it's useful. If I was in a library and I was looking at a book on, let's think, aardvarks, I could go to the A section of the library because I know that aardvarks begins with A, and I could find my book in there. Why I'd be reading a book on aardvarks, I do not know. If I was reading a book on elephants, well, I know I could go past the A section, the B section, the C, the D, and I would go straight to the E section because elephants would be categorized in there according to the letter that it begins with. Now, that is the next important point. It's the letter that the word begins with, not ends with. So we're looking at the first letter of each of the words, and that's how you decide where it belongs. So if a word begins with E, elephant, and a word begins with A, aardvark, A would come first in that alphabetical order. E would come next with those two words. You might have 5 words, in which case you would have to look and see where those words would fit into the alphabet based on their first letter. So let's take a look at what we're doing in our work today. So here we have the alphabet at the top. Like I said, as if you don't already know, it goes from A all the way through to Z. We're going to draw the foods in alphabetical order to make each shish kebab. Now here's a shish kebab, looks delicious to me. We are going to put these foods in order, okay? So we're going to draw them in order according to the alphabetical order they belong in. So we've got ham, onion, tomato, cheese and prawn. Now which one of those words would come first alphabetically? We'll take a look at the first letter of each of those words. Does H come first in the alphabet? Definitely not. There's some letters before that. So is there anything from the letters before that that these words begin with? Well, hold on a minute. We know that C is quite early in the alphabet. So C, is there a B or an A in there? There's not. So C would come first. I would draw the cheese on my shish kebab. What would come after that? Well, C, is there a D? No D's in there. E, no E. F, G, H, hold on a minute, I remember ham beginning with H, so I've got my cheese first, followed by my ham, okay, and that is how you will progress through this activity, looking for which word would come next in alphabetical order. We'll eventually get to this activity, and in this activity you should notice that these words, all begin with the same first letter. So how could we possibly put these in alphabetical order if they all begin with the same first letter? Well, as it tells you up here, it's the second letter this time we will look at, okay? We know that they all begin with S, so we skip the first letter because they all begin with S, and we go to the second letter. This one begins with H, C, E. So out of H, C and E, which comes first in the alphabet? Well, C comes before H and E, so this word would go first, scorpion. Secondly, H or E is the next two things to consider. Which one comes before the other in the alphabet? E comes before H, so seal, it would go scorpion, seal, and then that only leaves you the shark, so you could pop in shark over there. Now, Remember that it is the second letter. When the words begin with the same letter to start off with, you go to the second letter, and that helps you decide which comes first in alphabetical order. Good luck with that. Which leaves us with our topic challenge for today. So we're going to do a bit of a STEM design challenge today. STEM stands for Science, Technology, Engineering and Mathematics. So I found a lovely activity which we're going to have a go at in our house today as well, at designing a birdhouse. Now, what do you need for this? Very simply, you need a big milk carton or big milk jug. It can be a green top, it can be a red top, it can be a blue top, it does not matter. Here is what the finished article looks like. So you're going to design a little bird feeder like that. It can be hung up in the trees, and it will hopefully attract all sorts of different wildlife into your garden to have a go at those little seeds or nuts or whatever you decide to put in it. Make sure you're not allergic to nuts before you pop nuts in it. Holy smokes, make sure you don't put nuts in it if you're allergic. Now, the difficult part of this is cutting. Okay, so be very careful or ask for a bit of help to cut the doors into your birdhouse. Okay, that's the only concern I would have, is the cutting part. Everything else, it is up to you what this looks like. You come up with your own design and send them to me. Let me see what they look like. I would be delighted to see how they turn out. Hang them up, a little piece of string at the top. You can take the lid off, pass the string underneath it and screw the lid back on. That's a great way of holding it together with the string, and then tie it to the tree. Like I say, send them through. I would love to see them. Good luck. That is us for today. See you all tomorrow.